All right, so we're now in 4.10 applications of equations. So we're going to talk about exponential growth and decay applications. So hopefully you guys remember some of this stuff from algebra. But this one right here, we're going to be using a bunch of different equations. So first we have an equation which is like, I'll say A equals. So we have your initial amount. So whatever letter you want to put here. So this means initial whenever you have a little zero. So we have an initial amount. And then we're going to have some sort of increase your rate. So you could have like 1 plus or minus your rate. It would be minus if it's decaying. And then up to some time up here. So we'll put T up there for your time. And then we're going to use a couple different ones. So that's the one we're going to use for exponential growth and decay properties. And then there's one we're going to change it just a little bit on the back. So you can go ahead and read question 1, pause it if you need to, and then come back to me. Okay, so hopefully you read, and it tells you that your initial readers is 800. So that's my A0 is 800. And then I have a rate. It's going to increase, so it's a positive 0.25. And then we want to use an exponential model to find in which week we reach 10,000. So I have an end amount. So initial, I'm using this right here, 1 plus 0.25 up to some time. We don't know what the time, so I'm just going to put a T there. And so that's the model. And now we want to know when this will reach 10,000. And now we're just going to solve this. So we're going to use the properties that we just did yesterday. So my first step is to divide both sides by 800. And now I'm going to natural log both sides. You can log both sides if you want, whatever. And then divide. So grab your calculator and do natural log of 12.5 divided by natural log of 1.25. And that tells me the time is 11.3. So we would say in 12 weeks. Okay, so you're going to round up because it would hit it in the middle of that 12, in the middle of the 11th week. All right, go ahead and read number 2, pause it. Okay, so right here it tells us that we have an initial amount, so it tells you that it starts at 72 cents per share, and that 4 years later, the price goes all the way up to there, and we want to know what the rate was that models it. And then I should talk about continuous. Okay, the other one, if you remember from continuity. So this right here is just a regular rate. Sorry, my computer's frozen. There we go. That's the regular rate. And then we have the same thing. If it's continuous, though, we use it up here to a rate and a time, like that. So this is still your initial. That's E, the button in your calculator. And then you have an R and a T. Sorry, my computer keeps freezing. I was pointing to all this stuff. So that's the button in your calculator. R is your rate and T is your time. So this right here is for continuous. So write that down if you need continuous compounding there. And this is just a rate we have. So back here. So continuous we're going to use, and I used to call it PERT in Algebra 2, P-E to R-T, when we learned it. So we have, here's the end amount. I have 72 cents as my initial. E is the button in your calculator. And the R, I don't know yet. And the time is 4 years. And we're just going to solve this to figure out R. So divide over your 0.72. And then I would leave that decimal in my calculator, whatever it ends up being. Let me check real quick because I didn't do that part yet. Yeah, do you see how crazy of a decimal that is? So that's why I would just leave the fraction when I'm writing it. So I'm going to have natural log both sides. Remember, ln of E is 1. So you're going to have this decimal over here, and we're going to divide it by 4. So you should type in so what that looks like if you type in your calculator. So we have natural log and divide by my 4. And that is your rate. And so I need to write that, though, as a percent. So I'm writing it as 41.91%. So So that's a huge percent for those shares. I go ahead and read number 3. All right, and so it tells you that at what time would you have 100 milligrams remaining. So 500 is your initial. So I have 500 is my initial. And this time I'm saying half-life. So what that tells me is that my rate is a half up here. Or you could say like it's a 1 minus a half. So you end up with a half in the equation right here. So half-life, this ends up always being 1/2 in the exponent, or as that parenthesis. So I have 500 to start with. I have a 1/2. And then, so up here in the exponent, if it's every 5 hours is my half-life. So that would mean like 1/5 is my rate. Like, you have to think like in 10 hours, that would only be 2 half-lives. Or in 15 hours, that would only be 3 half-lives. So the way we write that would be like x over 5 up here. And we want that to equal 100. So I'm going to divide over my 500. And then I'm going to natural log both sides. And then divide that over. And then multiply that by 2. So let's see. So then, oh, why did I change that to a 2? Sorry, that should have been a 5. I'm losing my mind here. Sorry, it's early in the morning that I'm making this video right now, you guys. Sorry. So let's take this answer back. Multiply it by 5. So I get 11.609. So that tells me my x is about 61. So it means 11 hours and then 0.61 of an hour would be 36, almost 37 minutes. So I'm going to go ahead and round up to 37 minutes. So it happened at noon. So then this would happen 11 hours and 37 minutes later from noon. All right, when we're doing logistic growth models, you guys, they're going to give you the model right here. So when we are writing these out here. So they're going to give you a model. And if you read the question, they're going to give you H and they're going to ask you to solve for that T there. So you can take a second, pause the video, read it, make sure you understand. Okay, welcome back. So put the 50 right here. So we're going to treat this as a fraction, so cross multiply these. And then instead of like actually, well, I'm just going to go ahead and multiply these out. So subtract over my 50. Divide my 600. Gives me a third. And then I'm going to natural log both sides. Bring that out in front. Natural log of E is just going to be 1. So I'm going to have natural log of 1/3 divided by negative 0.72. So let's see what that looks like in the calculator. So natural log of 1/3 divided by, so then my time is 1.5, so 1.526. So that's weeks. So we'd say about 2 weeks. So same thing on the backup here. This is the same, but where you want to know, all right, let's see. So there's 6,000 fish, but it tells you right here that P is in the number of thousands. So instead of picking 6,000, you're just going to put 6 because P is already in thousands. So we're going to say, so cross multiply these. Subtract over my 6. Divide my 18. That would be, what, 1/9? And then I'm going to natural log both sides. Natural log of e will become 1. So I'm going to have natural log of 1/9. And then divide by negative 0.7. So I got 3.1. So my t equaled 3.139 years, because it says years right here. So you could say that it's going to be about 4 years, because you're not going to stop in the middle of the year. All right, now compound interest. This was your guys' favorite formula last year in Algebra 2. So when we do these, I'm going to put it up here at the top. So we still have your initial, but this time we have to account for how many times we compound. So remember, n is how many times we compound. So write that down on your paper if you need it. It's the same as the front except for with our n in it now. So this one here, we're depositing $500 into a retirement account, and the interest rate is this. So we have an initial of $500. My rate is going to be 0.04. And it's compounded quarterly. So that means that n is 4 because there's 4 quarters in a year. And we want to know how long it's going to take for the end amount to be that. So your initial formula would look something like this. And then I'm going to set that equal to the 1200. And then solve. So divide by your 5 first. And then let's do 1 plus 1.01. So natural log both these sides. And really you can divide the 4 at the same time here. So we would get, just make sure if you do this, I'm going to show you in the calculator, that you type this in right. So the entire bottom would have to get a parenthesis if you want to type it in all at one time like I'm doing. If not, so we get 21.996. So we're going to say about 22 years when it happens. If not, you're just going to do natural log of 2.4 divided by natural log of 1.01. And then you hit divide by 4 afterwards. Either way, you get the same answer. All right. So make sure you read number 5. We're ready to go if you have. Pause if you need to keep reading. So I have a deposit of $500. It's after 15 years. So my time is 15 years. It has tripled, which means that my end amount is now going to be $1,500. And it's compounded continuously, so we're using the PERT formula from the beginning. So remember PE to the RT. I said A naught, I think, on the front. But last year I called it PERT. And so would have most of your algebra teachers probably. So we have our end amount, our initial, E is the button in the calculator, the rate we don't know, and the time is 15 years. So divide that over. Natural log both sides. That cancels, so I'm going to get R equals natural log of 3 over 15. So natural log of 3 divided by my 15. Oopsie. So my rate is 0.0732. So it's about 7.32%. All right, last one. We invest $8,000. Pays a rate per year. Continuous, we're using the E formula. How long till we get to 10,000? So that's my end amount. And T, we're looking for. So let's do. So divide that over first. Natural log both sides. Sorry, it got dark in here. The light went off on me. Remember, LME cancels. So we should be doing natural log. So then my T is 2.975. So we're going to say it's going to take about 3 years for that to happen.